Dear viewers, greetings. In this video, we are going to see about types of infrared spectrometers. There are 8 types of IR spectrometers. They are dispersive infrared spectrometers, Fourier transform infrared spectrometers or FTIR, near infrared spectrometers or NIR, far infrared spectrometers or FIR, attenuated total reflectance spectrometers or ATR, photoacoustic infrared spectrometers or PAS, tunable diode laser spectrometers or TDLS, and finally microspectroscopy IR spectrometers. The first type of infrared spectrometer is dispersive infrared spectrometers. Dispersive infrared spectrometers were traditionally the most common type of IR spectrometer. They use a monochromator, usually a prism or grating, to disperse light into its component wavelengths. Working principle: a broadband IR sources emits light which is then dispersed into individual wavelengths. The sample absorbs specific wavelengths and the resulting spectrum is recorded by scanning through each wavelength sequentially. Advantages: this technique is simple and effective for basic IR spectroscopy. Disadvantages: this technique is relatively slow compared to modern alternatives as it scans one wavelength at a time. The second type of infrared spectrometers is Fourier transform infrared spectrometers. In short form, it is called as FTIR. FTIR is the most widely used type today due to its speed and accuracy. FTIR spectrometers use an interferometer to generate an interferogram which is then mathematically transformed into a spectrum using Fourier transform algorithms. Working principle: instead of scanning individual wavelengths, the interferometer splits and recombines IR light, creating an interference pattern called as interferogram. A detector records this pattern, which is then converted into a spectrum. Advantages: FTIR technique is faster data collection, high resolution, and better sensitivity than dispersive instruments. FTIR spectrometers can cover a wide range of frequencies in a single measurement. Disadvantages: FTIR technique is more complex and expensive than dispersive IR instruments. The third type of the infrared spectrometer is near infrared spectrometers. In short form, it is called as NIR spectrometers. NIR spectrometers focus on the near infrared region from about 780 nanometer to 2500 nanometer, where overtones and combinations of fundamental vibrations are found. Working principle: NIR spectroscopy is based on the absorption of specific wavelengths in the near infrared region by molecular bonds, particularly those containing hydrogen. Advantages: this technique is non-destructive and fast, often used for quantitative analysis of food, pharmaceuticals, and agriculture. Disadvantages: this technique is less sensitive to certain molecular vibrations when compared to mid-IR. The fourth type of infrared spectrometer is far infrared spectrometers. In short form, it is called as FIR spectrometers. FIR spectrometers works in the far infrared region where larger molecule vibrations and rotational transitions occur. Working principle: far IR radiation interact with the sample, revealing information about heavier atoms or larger molecule structures. Advantages: FIR spectrometers is useful for studying lattice vibrations, large molecules, and polymers. Disadvantages: FIR spectrometers requires specialized detectors and optics and less common for everyday applications. The fifth type of infrared spectrometers is attenuated total reflectance spectrometer or ATR spectrometers. ATR spectrometers are variations of FTIR that use a crystal with high refractive index. The sample is placed in contact with this crystal and the infrared beam reflects internally multiple times, interacting with the sample at the surface. Working principle: the IR light penetrates only a small distance into the sample and the absorbance is measured. This method is excellent for solid or liquid samples. Advantages: minimal sample preparation, ideal for solids, liquids or thin films. Disadvantages: limited depth of penetration, may not be suitable for all types of samples. The sixth type of infrared spectrometer is photoacoustic infrared spectrometers. In short form, it is called as PAS. In this PAS spectroscopy, the sample absorbs IR radiation, causing localized heating and thermal expansion. The expansion generates an acoustic waves which is measured by a microphone. Working principle: based on the photoacoustic effect, this technique measures the sound waves produced when the sample absorbs infrared light. Advantages: this technique is suitable for analyzing opaque or highly absorbing materials. Limitations or disadvantages: this technique requires specialized equipment and less commonly used than FTR technique. The seventh type of IR spectrometer is Tunable Diode Laser Spectrometers. In short form, it is called as TDLS. The TDLS spectrometers use tunable diode lasers as the IR light source and providing very narrow bandwidth and high sensitivity. Working principle: the laser is tuned to specific absorption lines of the sample, allowing for precise detection of trace gases or specific molecules. Advantages: this TDLS technique is extremely sensitive and specific, ideal for gas analysis and monitoring. Disadvantages: the tunable diode laser spectrometers are limited to certain wavelengths depending on the tunable laser which is used. The eighth and final type of IR spectrometer is Microspectroscopy IR Spectrometers. Microspectroscopy combines IR spectroscopy with microscopy, allowing for spatially resolved measurements on small samples or sample areas. Working principle: the instrument microspectroscopy IR spectrometers collect IR spectra from very small regions, providing detailed information about the distribution of chemical components in heterogeneous samples. Advantages: microspectroscopy IR spectrometers has a high spatial resolution, useful for material sciences and biological applications. Limitations or disadvantages: microspectroscopy IR spectrometers requires specialized instrumentation and often more complex data analysis. Dear viewers, that's all about the various types of infrared spectrometers. Thank you for your support. Thank you.